Hi everyone, Chad here. I have a new microphone. I'm really proud of my new microphone. I hope you guys can hear me really well. So today we're going to try to set up the um, ion exchange selection method that we tried to do, that we wrote last time. So this method has four different tiny 1 mil high trap fast flow columns on it, and like as it's depicted here. So that's kind of the tricky thing about this method. Everything else is pretty straightforward, and we're going to have a running buffer, which is 50 millimolar tris at pH 9, and that in that buffer, like those inlet lines for this is going to be A1, S1, and the sample buffer line. Like that's just to start. Eventually the S1 line is going to move over to the sample, right? And then we're going to have an elution buffer, and this is 50 millimolar tris as well, pH 9, that's got 0.5 molar sodium chloride in it. Now, if you watch that video, if anybody watches these videos, when I wrote the method, I had this as pH 8, both of these buffers, but I changed that because I wanted to be sure that the sample would actually bind to the columns. And I wasn't quite sure about the conditions. And it just exemplifies the need to be able to try different conditions, right? When you have something brand new and you're just trying to figure out how to purify it. Nothing works the first time. So here are some other kind of parameters for running this method. Let's get started by going over to Unicorn. And I just want to say before we go over there that I've already primed the entire system in water. Okay. Okay, so here we are in Unicorn, and we're already connected to the system. We got there by clicking this button right here. It says Connect to System, and we're on an Avant 25 this time. All right, so the first thing we're going to do is connect all four columns to the column valve, right? So we're going to go up here to Manual, and then we're going to select Execute Manual Instructions. So now what we want to do is start running the system so that liquid will start dripping out of the valve and onto the tray. So in chromatography, if you're not making a mess, you're doing something wrong. I want to do this because it'll help to limit the amount of air that we get onto the columns. So the first thing I'm going to do is I'm going to turn on the system flow to 1 mil a minute. All right, now that we've done that, we're going to go over to the column valve and set it to column position, and we're going to do column position 1. Now we could do upflow or downflow. If we do downflow, that means the liquid is going to be coming out of the top of the column, and then it'll eventually work its way around to the bottom. With the way the high trap columns work, you're basically going to want to plug, if you do downflow, with the way high trap columns work, you're going to want to put the bottom of the column into the top of the column valve. This way the column, it will be standing upright and you can see what it says. Okay, so here we are in Unicorn, and the first thing we're going to do is we're going to attach the columns. So like I said, the system's already been... So here we are in Unicorn. the first thing we're going to do is attach the columns to the column valve. So the system has already been completely primed in water, and we're going to go up here to start, and we're going to hit manual and then execute manual instructions. And then we're going to go to pumps, and we're going to turn on the system flow to 1 milliminute. The next thing we're going to do is go to flow path and select column position. We're going to select the first position for the column. Now when it says flow direction, we could do upflow or downflow. If we do downflow, that means we're effectively going to be running columns in reverse. That's fine. The columns work either way. Okay, now that we've attached all 4 columns, we have to prime the sample into the, onto the system, right? So the first thing we're gonna do is turn off the flow, system flow, 0.0, execute. Okay, the next thing we're going to do is we're going to start by priming everything. So I'm going to prime A1, insert, off, B1, insert, off, buffer, insert. Okay, execute. Okay, now that we've primed the system with each of the buffers that we're using, the next thing we need to do is actually put the sample onto the S1 line. And we're going to do this by going to the flow path radio button first and the injection valve. The system can't load, well, sorry, the sample pump isn't allowed to run while the injection valve is in the manual load position. So we're just going to set it to sample pump waste. And then we're going to turn on the sample flow. The sample is already set, the sample valve is already set to S1 because that's the last place we washed. So we're just going to turn on the flow rate to 1 milliminute. And then we're going to go lift the tube. Okay, now that we've washed the system and primed everything into its respective lines, we're going to actually load the sample onto the S1 line. And we're going to do that by going to flow path, and we're going to select the injection valve and set it to sample pump waste. The sample flow is not allowed to go until the injection valve is set to like the, damn it. Okay. So now that we have the system all primed in their buffers, the next thing we need to do is actually put the sample onto the S1 line. So we're going to do this by opening the flow path and select the injection valve. And on the injection valve, the sample flow and the system flow can't run at the same time. So only the system flow is allowed to run during the manual load position, which is what the injection valve is at right now. So we're going to do sample pump waste, execute, and then we are going to lift the tube now, and then when we're done lifting the tube, we'll turn on the flow. Okay, so the tube is actually in the sample, and we're going to turn on the flow to 1 milliminute. All right, now that that air bubble has gone into the valve, we're going to change the valve back to the buffer position. Whoops, we gotta hurry. Time is a factor here. Buffer, execute. All right, we're gonna let this run a little bit just to clear the sample pump out of like any air that's in there. In fact, since we're not running over any of the columns right now, I'm just gonna bump up the flow rate. And we're also not running like any sample over the system right now either. It's just solution. So we got plenty of solution. Just going to take a mill or two. Okay, that should be good enough. All right, so let's actually start the method now. All right, to start the method, we're going to go over here to the method navigator and click this. And so we're in the training folder. We're going to go down here to the method that we wrote last week, and we're just going to double click on it. You can right click if you want. This asks us if we want to save the manual run that we were just doing while we were attaching the columns and setting up the sample. I'm just going to hit discard. Okay. Give it a second to load up. All right. So we have to work our way through the start protocol. The first thing we have to do is work on the fraction collector. We've already loaded the fraction rack with a 96 well plate of fractions in there, which is great. Next, this is the variable list. There's nothing in here that we need to change, right? Then we're going to go to scouting. So these are the columns that we picked, right? While we were actually writing the method. If we wanted to, we could change one of them at the last minute. They're in the positions 1, 2, 3, and 4. All right, so I have decided, like while I was experimenting with this, I've decided that 10 mils is too much. We're going to do 5 mils. This sample's pretty concentrated. Like it can handle, the columns can handle 10 mils, but I don't need to waste 40 mils when I could just go through 20. Right? It's all about economics here for this. Okay. that is everything I think we want to look at. So system flush, 1 mil a minute. We're just going to review, right? That's what we're doing. System flush, 1 mil a minute. The sample load position right here is S1 the entire time. We're going to do every single run, load 5 mils, and we're going to have a CV of 7.5 column volumes each time. That looks great. Text instructions. This is everything we went through when we were writing the method. I have no notes. I'll just do tris TRISPH 9. I could write something like elution with 500 millimolar NaCl. Just real quick, right? Next. Okay, so then here's where we're going to put the name of it. So we're going to save this to the training folder. All right, right here. Okay. And start. Okay, so we just finished the run. It took about 45 minutes. Let's look at the results. So we're going to go. Okay, so the runs are done. So let's look at the results. So we're going to do this by selecting this first result right here, and we're going to hit shift, and then we're going to select the bottom one, and so that's going to highlight all 4 of them, and we'll hit this compare button, and this will open all 4 at the same time, and it takes Unicorn just a minute to be able to open these. Okay, so here's all 4 runs. The exciting thing is it looks like this orange curve right here, which was curve number 2, separated a single species. Now, this could be because the conductivity curves were off a little bit. So we'll check that. We also notice this blue line right here. There's another species right here. So that might be something we want to look at as well. First, let's check the conductivity curve. We want them all to be the exact same, one right on top of the other, and that will indicate to us that, like the little peaks that we're noticing on either side aren't artifacts, right? Okay, so looking at this, I would say all 4 of these curves are probably, yeah, these are good. So that means these species that we're pointing out here are different. Like this is something unique, and this resin is separating it, and same with this blue line right here. This is separating something. I'd say this is pretty good. All right, so I'm going to turn these off. All right, and then the next thing we want to know is what chromatography resin is this actually, because this looks like it's the good one to do. So we're going to go to view and then scouting variables, and we're going to select column right here. And when we select column, it's going to tell us what variable this was. So 2 was the high trap QXL column right here. So that's the resin I think I would use at least. This blue one, and it looks like the orange, like it looks like run like the high trap QFF resin was able to separate out this species, and so was the orange one, the high trap QXL. Let that be a lesson. Not all, like, even though both these are Q, like not all resins are the same, even if the ligand is the same. It's really helpful, like if you're gonna try in Q columns, to try a bunch of different Q columns, not only ones that are just made by Cytiva. You want to do like a bunch of different manufacturers. These are just the columns I happen to have on hand. All right, another thing I think it's pretty interesting is I think with run 3, there might be a little bit of a shoulder there too. Yeah, that might be, yep, I would say that's a shoulder as well, though it's not as nearly well defined as is the, so this is the DEAE. This isn't nearly as well as defined as the QXL. Let's turn those all back on. Right? Oh, wait, what am I looking at? Yeah, that's the primary peak. Hey, sometimes the zoom in can really get you. I'm used to just being able to right click here and just hit unzoom from reset. Where's the reset? Curve axis. There we go. Sometimes I struggle with this. Reset. There, that reset. Okay. Okay, great. So, yeah, I guess our answers here are QXL is probably the best one, followed by Q fast flow. The reason I like QXL more is because it can possibly identify a species to the left and to the right of the main peak. Though it just depends on what our impurities are. Sometimes we might end up, like, we might consider this to be a different species, or it might just be, you know, like a dimer of the same protein or something like that. So we're not really concerned about the difference between these two. And this peak, this front peak, is the one you may mostly be concerned about. So it just depends, right? So let's say we really want to separate out this peak right here. Let's say we want to work on that. I happen to have a little sample left. I have enough for 2 more runs. So what I'm going to do is I kind of want to just show you guys how scouting can get multi-dimensional, right? So we're going to go back to the control module, right? And we're going to set up another run. So ion exchange selection. And we've already done 1 run, right? I'm going to go to scouting. Okay, so we already did 1 run of QXL. So I'm just going to delete the other 4. So we're going to expand. The whole idea here is we're going to expand on the idea of QXL. So we're going to delete these. Other 3, remove, yes. Remove, yes. Okay, so let's do 2 more, all right? So we have here, in theory, we have 3 runs of QXL, all going to column position 2, right? All running at 1 mil a minute, all coming from the same sample inlet. And they all have, they're all going to be running 5 mils this time, right? And then they all have gradients of CVs of 7.5. Now, let's say we want to do 10 and 12. 12.5. So we're going to increase the length of each run by each gradient length by 2.5 CVs each time, right? This would maybe be able to get at what is, let's see here, evaluation, right? No. Yeah, here we go. So the idea is if we stretch the gradient out, all right, let's just turn these off and hopefully that'll concentration B there. So if we make this gradient longer, hopefully this peak will separate more from this primary peak right here. That's the idea. Okay, so control. But the thing is I only have enough sample for 2 runs, not 3. So I'm going to exclude this first run right here. So we're just going to test 10 and 12.5. All right, notes. Expanded gradients. R-A-I-D-N-T. Gradients. Next. I'm just tapping these in really fast, right? I-E-X. Gradients. Okay. That's being saved and training in examples and start. Oh, where'd it go? Control. Okay, so I'll show you the results when they come through. Evaluation, presentation, close result. Okay. So here are the ion exchange gradient runs we just did, right? I did this one, and so we're going to highlight these two. Actually, what I'm going to try to do is hit this examples. Okay, see if I can do this. I haven't. Okay, and 2. All right, so all 3. And then compare. Okay, so here we are. I'm going to do the concentration B, show those for each of these 3. All right, there we go. And this gets a little confusing, so I just wanted to show you each of the different gradients we got, right? All right, so turn those off. Okay, and this is kind of hard to see just as it is. I would say that the last gradient that we got a pretty good separation. These continue, each of these peaks continue to push away from each other, at least eyeballing it. Now, the real way to do this would you would get you do relative mobility, right? So you hit this data points button, and then you'd write down this, right? The primary peak versus the secondary peak. And then you divide them one by the other. So you get a percent of how that far away they are from each other. And then you do the same thing for the second run. So primary peak, secondary peak, and then primary peak and secondary peak. Now, in theory, if these peaks are, if the gradient separation is working, the percent difference in that's what I call relative mobility. So which is this number divided by that number. The relative mobility should be going it should be a different number. It shouldn't give you 65, 65, 65. It should be 65, 60, and then 55 or something like that. So you would see the separation get further apart. So if it was me, I would go with, at least for right now, having just done this one extra run, I would go with this third one right here. But there's obviously a lot more to be tested right here with just this QXL. Okay, thank you very much. I hope you found this helpful and not too meandering.